Here's number 23. This is in section 9.1. These are where you have to solve the triangle. To solve the triangle, you have to get all three sides and all three angles. Sides are lowercase letters, angles are uppercase letters. Please verify that the biggest side is opposite the biggest angle and the smallest side is opposite the smallest angle. That's a check you should always do after you solve triangles. Now, on to 25. They give us two pieces of information. I have to draw it. Okay, maybe you're better than me, but I kind of have to draw these out. Angle B is 75 degrees. So I'm going to call angle B 75 degrees. I know angle C is 90. When I add those, I get 165. If I subtract that one from 180, leaves me 15 degrees for angle A. So I got all my angles. Angle A is 15 degrees, 75 degrees, and 90. There's only one side I know, and that's A. Side A is 15. So depending on what we want to use, do you want to use 15 or 75 degrees?
75.
Brooke says 75?
I say 75.
I know. I'm trying to get Brooke to look up from her phone.
It was totally, yeah. I'm looking at, stuff.
There's a reason I said that. I'm sorry.
Yeah, I know.
Okay. Do you see 75? I know the adjacent, don't I? Do you agree if 75 I know the adjacent?
Yes.
Okay, so give me a trig involving the adjacent. Cosine. Cosine is adjacent over hypotenuse, right?
Yes.
So the cosine of 75 degrees would be adjacent over the hypotenuse.
Yes.
Adjacent next to it is 15. Hypotenuse is C. Solve it for C. C times the cosine of 75 degrees equals 1 times 15. What's the opposite of multiplying by the cosine? Divide by the cosine. And you'll get C to be approximately something. So, I have 15 divided by cosine 15. No. 75, right? Is it 75? It is B, right? Cosine of B, yeah. So I get 57.96. And that's C, 57.96. Now I'm going to ask somebody else for another trig that involves adjacent. Ryan, what do you think? Another one involving adjacent. How about TOA? Tangent is opposite over adjacent, right?
Yes.
Okay, so could I say the tangent of 75 degrees equals opposite, which is B,
B over 15.
over the adjacent of 15? Cross multiplying makes B into 15 times the tangent of 75 degrees. 15 times tangent 75 degrees gives me 55.98. 55.98. I think they want sides to 2 decimals. Now, do I have all three sides and all three angles? Let's verify. Is the biggest side opposite the biggest angle?
Yes.
Is the smallest side opposite the smallest angle?
Yes.
So at that point, I'm going to say we did it right.
Yes.
Okay, on to number 27. 27 gives me angle A to be 64 degrees. So I'm going to label it 64 degrees. I know angle C is 90 degrees. 90 plus 64 is 154. If I subtract that from the total angle in a triangle, which is 180, I believe that makes 26. 26. Now, I'm going to label angle B as 26. I'm going to label side B as 32. Now, since they gave me the 64-degree angle, I think I'd like to use it. What is a 32 compared to the angle? Adjacent, opposite, or hypotenuse? Compared to the angle of 64,
It's adjacent.
it's adjacent. It's next to it. So I need a trig that involves adjacent. Cosine is adjacent over hypotenuse, isn't it? Yes? So if I do cosine of 64 degrees, what's the adjacent? 32 over what is the hypotenuse? C. Solving it for C, C times the cosine of 64 degrees equals 1 times 32. The opposite of multiplying by the cosine of 64 would be to divide both sides by the cosine of 64 degrees. Punching that in your calculator, just 1 second. I think it rounds to 72.997. If you round that, it's going to round to 73. So angle C, or side C, is 73. Cosine is adjacent over hypotenuse. So you could have used Pythagorean, but we're doing trig.
Yeah.
So what other trig involves adjacent?
That would be tangent.
Tangent is opposite over adjacent, right?
Correct.
So if I said the tangent of 64 degrees, what's opposite 64 degrees?
9.
A.
Oh,
I usually do not use A lowercase a's because they look like nines. Over the hypotenuse of C. But I think I know C now. C was 73, right? So when you cross multiply, A is going to equal 73 times the tangent of 64 degrees.
Right.
I'm going to punch that in my machine and see what it gives me. So I get 64, I want tangent, right?
Yep.
So I got to do a tangent of 64 on this one. Times 73. Do you get 149, anybody?
Yeah.
0.672.
Right.
So A is 149.67 if they want 2 decimal places.
Correct.
Now, is the biggest side opposite the biggest angle? No. Here's where the problem lies. See what I'm saying?
Yep.
Look right here, guys. The biggest angle is 90. Is the biggest side 73? According to this, biggest side's 149 something. So that's not right. This is wrong. Sometimes you have to use a different approach, and you'll see what I mean momentarily. Okay, part of the reason I ask you to do that check is so you can find if there is a mistake or something was done wrong. I looked at it closely, and I think I found my mistake. Opposite over adjacent. If I'm using 64 degrees, the adjacent is 32, isn't it? I put 73, which is not correct. So I'm going to fix this up. What should the tangent of 64 equal? What is opposite? Opposite 64 degrees is A. But what's adjacent? 32. So hopefully this will work out better. Tangent of 64. Bear with me, I'll punch it in. So that makes A into 65.61. Now let's check again. Is the biggest angle and side opposite each other? And is the smallest angle and smallest side opposite each other? So now I'm fairly confident that we've done it correctly. This is the beginning of 9.2. We are converting degrees to radians, radians to degrees. Your key is this formula right here that's boxed in. I listed your major special angles in quadrant 1. And 0 degrees is equivalent to 0 radians. I'm about to find the other values. What if I want 30 degrees? 30 is degrees, so where does it go? Bottom or top? Bottom. I'm trying to find radians, so I put a variable like r on top. Cross multiply when two fractions are equal to each other. You get 30 pi. Opposite of multiplying by 180 is to divide by 180. And you get r to equal 3/18 or 1/6 pi. So 30 degrees is pi over 6. How could I do 45 degrees? I would use the same formula. Radians over to degrees. If I know 45 degrees, I know I need to put it on the bottom. So I put my 45 on the bottom. Put the r up here. Cross multiply. 180 times r equals 45 times pi. Divide by 180, divide by 180, and 45 goes into 184 times. So that means 45 degrees is equivalent to pi over 4 radians. Right? Would you agree with the trig table agrees with me? Is 30 degrees the same as pi over 6? Is 45 degrees the same as pi over 4? Okay. 60 degrees is pi over 3. 90 degrees is pi over 2. Learn them or derive them, one of the two. I'm sorry? At some point, you're going to want to learn these primary or special angles. When I start asking you for 150 degrees to radians, that's where it's going to be a little bit different because that's not in quadrant 1 anymore. So if you bear with me, I'll do it right here. Let's do 150. So you have pi over 180. That stays the same. That does not change, right? And what do I put 150? Top or bottom if it's degrees? Bottom. And I would put some variable up here that I want to solve for. Again, when two fractions are equal to each other, you can cross multiply. The opposite of multiplying by 180 is to divide by 180. And you get 15/18. 3 goes into there 5, and 3 goes into 18, 6. So this would be 5 pi over 6 radians. Look at the trig table, or your unit circle. What does it say 150 degrees is equivalent to here?
5x over 6.
5 pi over 6. 5 pi over 6. So in this section, we're going to do numbers 3 to 31 odds. Let's take a look at a couple of those. Angles have an initial side. The initial side never moves. That stays there. And I want to go, positive angles go counterclockwise. So you go up this way, and I'm making an angle of 70 degrees. This is called the terminal side. If you are ever asked, like number 15, for coterminal angles, that means they have to have the same terminal side. Please listen. They want one positive and one negative. Could I end up at the exact same place by doing this? Could I go 360 degrees? Does that get me back to the beginning?
Yes.
And then 70 more. Would that put me on the same terminal side?
Yes.
So what is 360 plus 70? I'm sorry? 430 degrees. And do you agree that's a positive coterminal angle? Now, negative angles go clockwise. So if I go this way, How much less than 360 would that be? Negative angles go clockwise. If you did 360 and took away 70, that would leave you 290. But because it's negative, it's clockwise, it's negative. So there are two answers here, one positive and one negative coterminal angle. Now, some of you will notice, aren't you basically just simply adding 360 degrees and subtracting 360 degrees?
Yep.
That's all you're doing.
Us.
Now, but what if it's 500 degrees and you want to make it negative? You might have to subtract 360 twice, right?
Right.
Anyway, good luck with this.